Hello guys, I hope you guys are doing well. Yes, I quickly want to pass this across to you. I observed I left out one important lecture, and I think I need to just do justice to it before you guys go into the exams. In fact, I promised that there will be one last lecture, but because of the midterm we had on the last day, I wasn't able to do that lecture. But permit me, it is on search. In fact, I have set questions on it already, so it suffices that I walk you through it to prepare you for the exam. It is not that difficult. You have done this in the lower classes, like in the data structures before. So I will just walk you guys through it so that you have the in-depth understanding of it and apply it to artificial intelligence. Now, we have different types of searches. We have the basic idea of a search that has to do with you looking out for something to solve a problem. Somebody might be looking or searching for a girlfriend. That is his problem at that moment, so it's solving a problem. Vice versa, somebody used to be looking for a husband or a boyfriend. Okay, so that search answers a problem. And we are saying that a search is an important approach to a general purpose problem solving technique. And search techniques are most important and pervasive when it comes to general artificial intelligence. All right, so search is more like a mental exploration of possibilities. So we have different degrees of search. And examples of search here we have: before deciding to move as a chess player, you want to consider some moves you would want to take in order to do what? Win some points. Okay, so we have different types of search. Assuming you want to even travel from Boko down to somewhere in Accra, you will definitely use some paths, in other words, what we call shortest paths, to get to your destination on time and on schedule. All right, so we have what we call the search that enables us to go through a particular route. Okay. Now, the most important thing about this is for us to know how to formulate the search problem. You need to initialize it, give a goal, and also give certain parameters, in other words, permissible operators that would be allowed in your search strategy. Now, in search strategy, we have what we call a state and the state space. A state is one status of the problem, whereas the state space is a collection of the states, so a collection of problems, so to speak. And so we have types of search problems. We have a single state problem, we have the conformant problem, we have the contingency problem, we have an exploration problem. Exploration means the unknown. You are going like all out. All right. And an example is a vacuum cleaner. How it goes about is search for dirt, to clean. And quickly, we'll move into the strategies that are available. Yes, so let me go to the search strategies. We have the key concept, and that is to find a solution while realizing in memory a few possible nodes. Okay, so when it comes to search, we are trying to carry out a problem solving technique, okay, that would involve some decisions to be made. Okay, and then we have these strategies as we have the uninformed search. In other words, the blind search. All right. We also have what we call the informed search or the heuristic search. All right. So it's going to play between this, but my major area for you to concentrate on will be the family members that has to do with the depth first search and then the breadth first search. So concentrate on these two: depth first search and then the breadth first search. So this is where I would like you to look at. And the breadth first search is a pseudocode, okay, to carry out the breadth first search. Okay, so you first of all you open or you start your search. If it is closed, it means it's empty. So you open it up. Then what do? If it is not empty, you do what? You remove the first state, okay, and call it X. So this is just a way of going through the algorithm. But the actual thing is that the algorithm for the breadth first search is the list open, okay, where we have the queuing system, where we say FIFO, first in, first out, all right? And then we have the depth first search algorithm, that is the stack, that is the LIFO, last in, first out. Definitely, when you go to a bank, you can't go and say the last person on the line will be served first. No, okay. So, but you know, in banks, I always say we have what we call the prestige banking. Okay, people who might have more than you in terms of monetary prowess, when they get to the banking hall, they can be given attention more than you, the guy with just some few coins in there. So it doesn't really follow that the FIFO, first in, first out. No, or another first come, first serve. No, it's kind of dicey when it comes to that. All right, but this is the breadth first search. Assuming this is the beginning of the node, this is the root node. Okay, now these towers you are seeing here, this simply means that it's enqueuing. All right, so if it pops up, then it enters in there, and then it follows. So with the breadth first search, we are saying that we are looking at those level kind of order. Is what we call the level order search, where we look at the node first, then we move on to the closest neighbors. The closest neighbors here are what? B and C. Then after that, you move on to the next one. The closest neighbors will be what? D, E, F, G. You get it? So it goes in that order. So when you are even stating it, you say A first. You can see here, all right, followed by B and C. You see, then followed by D, E, F, G, D, E, F, G. All right. So it goes in a sequential. In other words, what we call the level order. That is the breadth first search. So consider that done. And then with the depth first search, we are looking at the extreme. So in other words, just like you having the opportunity to help people, instead of you helping people within first, you prefer to look at people outside. That's what Kwame Nkrumah was doing. Instead of he helping the people inside Ghana, he wanted to, for the total liberation of the African continent, he wanted to help outsiders before coming inward. So that is what the depth first search does. It looks at the extreme before coming to the inside. So you can see here that as we pop A will always be the starting point. But look at this, we'll come to B, all right, then go to descend to D, all right. So if you are not in breadth with him, you don't get any privileges. So we go straight to B, then the people connected to B will be looked at first, okay. So we come to B, then D, E, before we move to what? C, okay. Then at C, we look at what? F and G. I get it. So it goes in a particular sequence. All right. So when you are coming to do this the first search, you look out for it's not level order. So you know that in this case we're not going like levels. All right. We are just going straight to the very extreme ends before we look at those who are closest. All right. So that is what the depth first search is all about, and you will be presented with a simple case like this, okay, to solve the problem. That is not that difficult. So we are done with the first one. Then the second one, we want to look at the graph structure. In other words, in terms of trees, we want to look at how we can get what we call the adjacent matrices. The adjacent matrices. So here we are saying that with the first case where we were looking at the list, where we look at the stack, all right, or the queue, it was a one-dimensional data structure. All right. Now we want to look at the two-dimensional data structure, that is the tree. Okay. So you realize that, assuming I had given you this to look out for the depth first search and the breadth first search, it would be easy for you, right? So you consider this. All right. At this point, we might this might come. Okay. So we look at the root first before we consider the children. All right. And the children are what? The children are the nodes below the roots. Okay. So there are certain terminologies you need to know. We have the path, we have the levels that represent the level of edges. All right. So you need to have this in mind. Then we have the multi-way tree and the binary tree. Multi-way definitely is more than, in terms of branches, more than two. So that is why we say it must actually, for it to be considered as, if it's just two, then it means it's just binary. But if it's more than two, then we say multi-way. Okay. Now we are trying to, let me move straight to the point of interest. So in terms, we are saying the matrices, okay? So in terms of the adjacent matrix representation, we are trying to say that a matrix A is of a value n by n matrix. So in other words, the number of, you know how matrices can be considered, okay? We have, this is in the form of a matrix form. So how do you get the path for this in terms of the matrices? What we're trying to say is that you can see that here there are no distinct arrows being shown in this particular figure, okay? Hence making it easy for you to know where it's just connected. So you can see that 2, 5 are connected to 1, all right? And you can see here too that 1 connected to 2, 5 connected to 2, 4 connected to 2. Then, so when it comes to the formation of the matrix, we split it. So we say, well, another we call it the decomposition. We call it the decomposition. All right. So to go about that, we say we split it. We have a majority of what? We have 1, 2, 3, 4, 5. So you lay it out this way. That you consider 2. So 1 to 2, you realize that it's possible. Then 2 to 5 is possible. All right. Now beyond the 1, see that it has ended. So we put this there to indicate that it has ended. Its connection has ended. Now when we come to 2, 2 has a linkage to 1. It's possible. Okay. Has a linkage to 5. It's possible. And then has a linkage to 3. Yeah. Then also has a linkage to 4. Right. Then the case closed for it. When we take 3, well, that 3 has a connection to 2, and has a connection to 4 as well. But beyond that ended. We have 4, which has a connection to 2. We also have a connection to 5 and has a connection to 3. Then the case closed. So in that, we are just trying to say that we are looking at the paths that are possible with the nodes. Okay, so when you take 5, it's possible to connect to 4, connect to 1, and connect to 2, then case closed. So the matrices will be like this. So when we look at this particular situation, we are saying when you take 1, does it connect to 1 itself? No, so you put 0. Does it connect to 2? Yes, it connects to 2, so 1. Does it connect to 3? Yes. Sorry, we are referring to 1. We're referring to 1. So when we take 1, does it connect to 3 directly? No, it does not connect to 3. Does it connect to 4? No, it does not connect to 4 directly. Does it connect to 5? Yes, if you come down here, you can see it. So this is actually what will be used to generate the matrix. You remember when we were doing the confusion matrix, all right? We have something like this, but this actually is peculiar to a search strategy. So the same way, we can look at this particular figure, but this particular figure has arrows, if you look at it carefully. So these arrows are pointed, meaning that they have a particular direction in which they go, all right? If you don't look at, see arrows in there, you might not be able to answer the questions appropriately. So the arrows are indicative of where it is going. So in the same vein, okay, we can split out and get the matrix. So when we take 1, that's 1 work on itself? No, but it's able to move to what? 2, yes, which means it's possible. Does it move to 4? No. Does it move to 3? No, 3 is far away from it, so obviously 0. But 4, yes, it moves to 4, so you see. So in that context, now there's something unique here I want you to look at. Look at 6. You can see that 6 moves or rotates on its axis, meaning that it's moving, pointing to itself. So you see that when it comes to 6 is what? 1. Okay, note about that. All right. So in fact, what I'm just talking about, that this is coming. Kindly look at it carefully, and then be able to answer your way through. All right. Okay. So let me see whether. Okay. So yeah, this is the end of it. This is the short awareness creation. Kindly look at it carefully. All right, and you should be able to have it easy during the exams. I wish you all the best. Thank you for listening.